Hello, and welcome to our 10:30 a.m. press conference, the Arctic Report Card. And I'm going to introduce Monica Allen from NOAA Public Affairs, who's going to introduce the panel.
Thank you, Nancy. Welcome, everybody. Welcome those in the room and those online for the Arctic Report Card 2016 press conference. I want to just point out to you that a couple of things. If you have questions, you can, afterwards, you can reach me. My email is there, monica.allen@noaa.gov. And also, if you want the images from the slides, they should be at www.climate.gov. And if you have any trouble with anything, please let me know, and I'm here to help you. Now I'd like to introduce our panel. We have, leading off the panel is Jeremy Mathis, who is the director of NOAA's Arctic Research Program and one of 3 report card editors. And next to him is Don Perovich, who's an adjunct professor of engineering at the Thayer School of Engineering at Dartmouth College, and the lead editor for the sea ice essay. And we have Marco Tedesco, who is the Lamont Research Professor at Lamont Doherty Earth Observatory at Columbia, and Marco is the lead editor for the Greenland Ice Sheet essay. And I also want to make sure that you're aware that we have the Arctic Report Card is on our website. The website's right there, and it has a very short video that summarizes it. I encourage you to use that, embed it. It really encapsulates the story. And now I turn this over to Jeremy.
Thank you, Monica, for that introduction, and good morning, everybody. It's great to see you all here, that we have a standing room only crowd for the Arctic Report Card this year. NOAA and our partner scientists from around the world have been tracking the Arctic and putting out the annual peer-reviewed Arctic Report Card for the last 11 years. And I'm really proud to say that this year, the Arctic Report Card represents the work of 61 scientists from 11 different countries. And that's really important this year because we've seen a year in 2016 in the Arctic like we've never seen before. The report card this year clearly shows a stronger and more pronounced signal of persistent warming than in any previous year in our observational record. And those warming effects in the Arctic have had a cascading effect through the environment, including down into Arctic ecosystems. And while the science of what's driving that change gets clearer, we need to expand and improve our ability to do sustained observations in the Arctic. And we need to do these sustained observations to help provide actionable information and intelligence for forecasting that people desperately need in the Arctic, as well as other stakeholders who are looking to take advantage of emerging opportunities in the Arctic. The issues that we're facing today in the Arctic include food security, cultural survival, environmental and community health, as well as extensive development opportunities. And these opportunities are related to commerce and trade, and as well as national security. And this was made evident back in September when the White House hosted the first ever Arctic Science Ministerial. And I'm really happy that we have several leaders from that ministerial in the audience with us today, including Dr. Martin Jeffries and Dr. Brendan Kelly. And the ministerial brought science ministers from 25 countries to the White House to talk about the challenges and the opportunities that we're going to face in the Arctic. And remember that there are only 8 Arctic nations, so the fact that we had more than twice as many non-Arctic countries participating in the Arctic Science Ministerial tells you how seriously this is for global processes and global challenges that we are facing. So with that, we're going to take you through a summary of the Arctic Report Card this morning. There are a great many more details in the report itself, so I encourage you to look into it carefully and read the nuances in the chapters. They're all very short, but each chapter has a very important message for the changes and some of the implications of those changes that we're seeing. So with that, I'm going to turn it over to my colleague, Dr. Don Perovich, who's going to take us through the first part of the report card.
persistent warming trend in air temperature over the Arctic is driving the changes that we are observing, as you can see in this plot here. Arctic air temperature continues to increase at double the rate of the average global temperature. Since the beginning of the 20th century, Arctic-wide annual average air temperature over land has increased by 3.5 degrees Celsius. That's 6.3 degrees Fahrenheit. Between October 2015 and September 2016, this air temperature was 2 degrees centigrade, or 3.5 degrees Fahrenheit, above the 1981 to 2010 baseline. This marks the highest value in the observational record, a record that began in 1900. Autumn, spring, and winter showed extensive warm air temperature anomalies across the entire central Arctic. This was primarily due to southerly winds moving warm air into the Arctic from mid-latitudes. However, there are also cold temperature anomalies across the central Arctic Ocean in the summer of 2016. And these air temperatures influence the sea ice cover of the Arctic Ocean. After experiencing the lowest winter maximum sea ice extent in the satellite record, a satellite record that began in 1979, many anticipated a record summer minimum extent. But relatively cold summer air temperatures over the Arctic Ocean prevented that. However, due to extreme warming this fall, the report card editors decided to add an addendum to update several indicators, including sea ice. Warm air and ocean temperatures in the fall led to a record-breaking delay of fall freeze-up in the Arctic sea ice. From mid-October to the present, the ice extent has been the lowest observed since the beginning of the satellite record. Again, a record that began in 1979. In August 2016, sea surface temperature, as the sea ice retreats in the summer, previously ice-covered water is exposed to more sunlight. Unlike the white surfaces, which reflect sunlight, the dark ocean absorbs the sun's heat. This is causing sea surface temperature to increase throughout much of the Arctic Ocean and adjacent seas. Relatively warm regional air temperatures and warmer water from the North Atlantic and Pacific Oceans are also contributing to these warmer upper ocean temperatures. In fact, in August 2016, sea surface temperature was up to 5 degrees centigrade. That's 9 degrees Fahrenheit, higher than the 1982 to 2010 average. This was in regions of the Barents and Chukchi Seas and off the east and west coast of Greenland. Ocean primary productivity, or algae blooms, are also increasing as the summer sea ice declines. Increased algae blooms are observed throughout the Arctic Ocean and adjacent seas, particularly in the Barents Sea and in Canada's Hudson Bay, where primary productivity was 19% above the 2003 to 2015 baseline. These conditions in the Arctic Ocean make it more prone to ocean acidification. This is compared to the rest of the global oceans because ocean acidification is caused by the uptake of increased human-caused carbon dioxide emissions. The Arctic Ocean absorbs more carbon dioxide because it is relatively cool and experiences a relatively high influx of fresh water from melting glaciers and sea ice. Marine calcifiers like clams and snails, which build shells, are particularly vulnerable. Over the next 2 to 3 decades, ocean stress on Arctic-based marine fisheries and the Arctic communities that depend on these fish for food, culture, and livelihood. This will put new stresses on all of these systems. Now, to shift to more of the report card, I'll turn things over to Marco.
Thank you, Don. Now let's shift on land, on ice and snow on land. And let's start with the Greenland ice sheet. The Greenland ice sheet continued to lose mass in 2016, as it's done since 2002, when satellite measurements are available. The melt onset was also in 2016, was the second earliest in the 37 record of observations from satellites, close to the record of the 2012 by few days. The melting season lasted up to 30 to 40 days longer than usual in the northeast Greenland, and 15 to 20 days longer along the west coast, compared to the 1981-2010 average. Shifting to spring snow cover, the snow cover extent has also declined over the period of satellite observation starting in 1967, and particularly since 2005. In 2016, a new record low of April and May snow cover extent was reached in North America. Warming Arctic surface air temperatures have a clear influence on the timing of snow melt onset. However, there's also evidence that snow depth is decreasing, and which might precondition also snowpack for earlier and more rapid melt in the springtime. Following 3-4 years of decline of browning, tundra greenness, a satellite measure of chlorophyll, generally increased throughout the Arctic between 2014 and 15. Longer-term trends show a mix of greening and browning varying on a regional basis. Still remaining on land, warming air temperatures in the Arctic are causing normal frozen ground called permafrost to thaw. The permafrost is carbon-rich, and when it thaws, it gives off greenhouse gases such as carbon dioxide and methane. Tundra ecosystems are taking up increasingly more and more of this carbon during the growing season over the past several decades, but this has been also offset by increasing carbon loss during the winter. And overall, we estimate the tundra is actually releasing net carbon to the atmosphere. And now I'm going to give the word to Jeremy again. Thank you.
So as I said, that was just a very brief overview of what's in the report card and a high-level summary that we wanted to provide this morning to facilitate the questions that we want to be able to take from you. And so before we go into the question phase, I just want to summarize that the impacts of the persistent warming trend over the last 30 years in the Arctic are clearly evident in the land and the ocean environment. And the acceleration of many of these signals, their interdependency, and the growing recognition that the Arctic is an integral part of the larger Earth system have increased the pressure for more effective and timely communications of data to our relevant communities. And as we've started saying more and more, what happens in the Arctic doesn't stay in the Arctic. We look to meet these challenges by better synthesizing Arctic change across disciplinary boundaries and taking a holistic approach as we think about Arctic science. And as we move forward with products like the Arctic Report Card, we're going to be thinking about ways to use it as a tool that can not only present our scientific findings and summaries of the science that has occurred during the year, but also to begin to think about strategies and adaptation solutions that can be applied for communities in the Arctic and for people around the world as we deal with the consequences of Arctic change. So before we close and take questions, I certainly want to thank everyone who had a role in Arctic Report Card this year. We had dozens of authors and contributors that have worked on this for a number of years and really make a sacrifice of their time and their effort to make the Arctic Report Card possible. We have leaders throughout the U.S. agencies and within our university systems and our international colleagues around the world who make the Arctic Report Card possible. And I'd certainly like to thank my two colleagues who are up here with me today. So with that, we're going to open it up to questions and be happy to answer anything that you have.
Great, thank you. We'll now open up to questions. As a reminder, only registered reporters are allowed to ask questions at this time. If you please raise your hand and state your name and affiliation.
Hi, Maddie Stone. I'm the science editor for Gizmodo. I was hoping one of you could talk about the 2015 El Nino and how that signal has shown up in Arctic sea ice, and to what extent the dramatic warming we've seen and the slow fall freeze up we've seen can be related to El Nino, and whether we're expecting to see as large of an anomaly this coming year as we move into a La Nina phase.
I don't have any expertise on El Nino.
Sure. So how about I'll start with that one. We certainly recognize that El Nino was a major player this year in our global ocean system, and the warming that was created by El Nino certainly played a role in the warming that we saw in the Arctic. we haven't been able to definitively attribute specific amounts of warming in the Arctic this year to El Nino. So we'll be working on that in the coming year because I think it is an important process, and it really emphasizes the fact that we've been trying to make, that the Arctic is part of the global system and is impacted by global processes like El Nino, but also has the potential to impact global system on its own as the Arctic changes. So we do know, or we feel fairly confident, that El Nino did play some role in the Arctic warming that we've seen throughout 2016, but we'll work to quantify what exactly that contribution was over the next few months.
Randy Shostak, reporter with EOS. I wonder if you could tell me what impact do you think this report will have on the incoming administration? And related to that, how would you frame this report and its conclusions to have the biggest impact, the most favorable response from the incoming administration?
Sure. Well, we published this report as a peer-reviewed science document to provide information to the American people, to our administration leadership, and to people around the world. So I don't see the role or the mission of what we do with the report card changing. I think the Arctic Report Card provides us with an opportunity to explain the changes that we're seeing in the Arctic and to put it into a context that people can understand. And so we're going to continue to frame it in that way. As I said during my opening remarks, the Arctic is changing, and the Arctic will have an impact on commerce and economy and people's lives, not just in the Arctic, but throughout the Northern Hemisphere. So we will continue to work and continue to prioritize the effective and timely release of information from the Arctic, just like we've done for the past 10 years.
I'm Ned Roselle. I write for Alaska newspapers. A couple of years ago here, Mark Serez was talking about reaching a tipping point, particularly with sea ice. With the drama that you guys have seen this past year, do any of you think that's been reached? Do you have that feeling that there's been this big change that it's going to be hard to recover from?
Well, it's certainly been a dramatic fall with the lack of ice growth. I think in terms of tipping points, it's not a true tipping point in that the sea ice could recover if temperatures cooled off, which isn't that likely. The way I look at this is what we're seeing right now is the first act of a three-act play. That we're seeing the fall freeze-up has been very slow, and we have a record minimum ice extent. Act 2 will come in March when we see what the maximum is, and Act 3, of course, will be next September. I kind of await that with both anticipation and a little bit of concern.
Do we have any questions on the chat?
Yes. Seth Bornstein of the Associated Press wants to know, this is a question for Marco. Is there a way to quantify the permafrost loss, and is it worse than ever at record levels now?
Well, I'm the lead author of Greenland, and I think there is in the audience somebody, Ted, who took care of the permafrost and is more an expert. So I'm actually asking for help from him.
Yeah, my name is Ted Schur. I'm from Northern Arizona University. I'm a specialist on permafrost and permafrost carbon, and an author of the Permafrost Carbon Indicators chapter of the report card. And addressing the question about permafrost, which was not updated in this year's report card, but the trends for permafrost temperature are very similar to sea ice. And while we don't have a full analysis of 2016, we were hitting permafrost temperature records as of 2015, which is the latest year of updates. So there seem to be similar trends on land as compared to the ocean, but of course permafrost temperatures are lagged somewhat in time, but we see the same kind of trends that are reported here. Thank you.
And we have another question from the chat.
Yes, Seth had another question and didn't specify to whom it addressed. If this is a real report card, what is the letter grade for the
What is what? Sorry, can you repeat the question?
What's the letter grade for the report card?
If this is a real
okay.
report card, what is the letter grade you would give it now, last year, and 10 years ago?
From an observational point of view, 10. We have much better tools now. We can better diagnose things, and we know much better how the systems and the components of the systems are connected. And we are starting to understand better and better how these connections are evolving, how the processes are impacting each other. So I would say, given the observations, given the expertise that is contributing to the report card, I would probably give it 10, but I'll probably give it also maybe 11 next year. So that, I think we're making great progress because of the effort, the continuous effort, and we are doing much better and better. So I will give it a 10 this year.
In terms of the sea ice, I'll give it the grade, and just to let you know, I'm an easy grader by nature. The back in the first report card, I gave the sea ice cover a B-. And this year, I'd say it's a D+, again, just because I'm an easy grader. And one of the things that when you look at this, we've been doing the report card for 11 years. And when it started, you kind of had to listen closely because the Arctic was whispering change. And now it's not whispering anymore. It's speaking change, it's shouting change. So these changes are occurring, and they're large.
Thanks. Irene Klotz with Seeker. I have 2 questions. I'm not sure who'd be best to answer this, but the first question is about the statement you made about the impact on economies and people's lives in the Northern Hemisphere, beyond the Arctic. Can you maybe give a few examples of what you're talking about and when that might be an issue?
I can probably start with this. Sure, go ahead. Yeah, for example, for the snow component, if you think about in North America, when the snow melts, how much snow you have, how fast will disappear, it's impacting a lot of activities in terms of hydropower production, for example, freshwater resources, but also it's impacting the ecosystems around it. The snow melting sooner and faster is leaving a drier soil exposed to a warmer summer. So you might have more drought, you might have more forest fires. So this might have, of course, ramifications for the economy, for population. Permafrost thaw, of course, has a big impact on infrastructure in Alaska and other places where it was considered to be permanently frozen, and now it's not anymore. So these are some of the examples, for example, in the case of snow and permafrost.
And I'll add to that we are obviously seeing challenges in the Arctic, and particularly in places like Alaska, that we're going to have to invest resources in. So as American taxpayers, if we're spending money to deal with challenges that are facing the Arctic, that's something we are all going to have to appreciate. And the other side of that is that there are opportunities that are emerging in the Arctic, whether it's new commercial shipping routes or resource exploration and extraction, or even tourism. There will be new opportunities in the Arctic that allow us to grow commerce and support the economy. So it will be a trade-off over the next few decades as the Arctic changes. We just need to make sure that we're providing the information to the residents and to the stakeholders so that our responses are effective and as good as they can be.
Thanks. And based on what you've been seeing over the past 11 years and understanding the tools for doing your diagnosis are better now than they used to be, what do you project happening in like 10 years?
Better tools, hopefully. The thing is that the Arctic report card is mostly based on the observations, and we use these observations also to validate, assess how our models are working. And this is a work in progress that we refine what scientists call uncertainties, which is how well we can predict by when. And so we are refining these tools and using these observations. The models are projecting, of course, a warming. How the different areas are being impacted is something that we are gathering again the picture of how the different pieces, components of the Arctic are interacting, and this is a crucial factor for better improving our projections. So we have a good understanding of what will happen over large scales. If we want to start looking at the detailed and how the different components are impacting each other, we are working on improving the models. But in this case, the observations are fundamental for this task.
Thanks. I guess I meant,
Oh,
I wasn't really clear, but I meant, what do you see happening in the Arctic in 10 years based on the trends you're already seeing?
Well, I think it's very hard to predict in 10 years by what we see with now. The Arctic is going such a strong change. We know that the processes, the basic processes we know are working fine with the models, but we need to account for these new processes, especially, for example, the link between the mid-latitude and the Arctic. How is our changes in the mid-latitude are affecting the Arctic, and as Jeremy was pointing out, and vice versa, how is that happening? We started to look into this as a community. There is big progress in this direction, but this is a key factor for helping us to understand how things will evolve in 10, 50, or even 100 years.
I think we have some more questions for the chat.
This one's from Maura Forrest from Arctic Deeply. She says, how concerned should Arctic communities that depend on subsistence activities like hunting and fishing be by this year's findings?
Don, you want me to take that one?
No.
You can go for it.
Do you have any?
I do.
Yeah,
Honestly, I think they should be very concerned, and I'll repeat the question to make sure everybody heard it. How concerned should Arctic residents be by the findings that we've shown this year in the Arctic Report Card for their food security? And I think they should be concerned because it's getting harder and harder for them to harvest resources as the ice pulls back further and further away from the coast. And that's a place where we need to be focusing our attention and our efforts to help them either continue to find those food sources and to rely on those food sources, or think about ways that we can help them deal with the loss or the decline of the food sources. So I think the challenge is there. I think the opportunity is for us to help them in the best way we can.
I think we have another question on the chat.
We do. This one is from Yerith Rosen from the Alaska Dispatch News. What do you think the Arctic will look like in 20 years or later? When will summer sea ice be gone? What kind of animals and plants will be new to the Arctic? He admits it's kind of a broad question.
Well, maybe I'll start off with just a narrow part of it with the sea ice. It's a common question, when will the Arctic be ice-free in summer? And it's important to remember, in summer there'll still be ice in the winter. There's a lot of speculation. If you look at model projections, around 2040. But again, that's just an estimate of an unknown future. Another interesting question to pose is, when will the reduction of sea ice be so large that it impacts human activities? And I like that question because that's one I can answer. And that's right now. We've seen it in increased resource exploration. We saw it this past summer with the cruise ship, the Crystal Serenity, navigating the Northwest Passage, that more than a century ago, no one could get through at all. So I think we're seeing changes in the sea ice cover now that are impacting human activities, and it's a particularly difficult time because the ice is in transition, and transitions are always particularly difficult to predict.
Can I add something about Greenland as well, probably, if I'm allowed to?
Go ahead. Yeah.
So in the case of Greenland, models project more melting in any of the CO2 scenarios for the next 100 years. They also project more snowfall for a short-term period, 20, 30 years, which in turn might then become rainfall. So all this will be conveying toward a more surface melting and more mass loss in the case of Greenland. But this is not only the point. The important point is also where melting is occurring. Affect, again, as Jeremy was pointing out, fisheries, ecosystems. Greenland is releasing more fresh water in the surrounding oceans. It's changing the balance between salinity, temperature profiles, and this has a huge impact on the ecosystem surrounding at a short-term scale nearby in the fjords regions for large-scale ocean circulation, and also the snow that is melting in North America and in Siberia is all fresh water is going to the Arctic Ocean, which then flows through the straits in Greenland Straits and Davis Strait into into the coast of Greenland. So we're projecting increased surface melting, increased runoff, increased freshwater discharge into the ocean in any of the CO2 scenarios that have been suggested for the future.
Bud Ward with Yale Climate Connections. I'd like to follow up with a question that Randy asked. To what extent, if any, is the integrity of your report dependent on ongoing work, in particular from NASA GISS? And if that work were substantially curtailed, how might it affect your report? Secondly, can you say, let me just settle for that one question to start with. I would like one follow-up.
Sure, that's a great question. As I said, we have a number of contributors that make the Arctic Report Card possible. So we hope going into the future that our scientists and researchers still have the opportunity to contribute and make possible the summary that we're able to present. So we have every intention of continuing to publish the Arctic Report Card as we have in the past, and pulling together the resources and the right people that allow us to do that.
And a follow-up, Jeremy, some of what you suggested going forward imply, or at least I infer, additional resources for this report, additional activities. In the event that you're not provided additional resources, or in the worst case, where the Arctic Report no longer existed, how might decision makers or the public be disadvantaged by the absence of an annual Arctic report?
Well, that's a great question. We hope that the Arctic Report Card is the vehicle by which we can inform the general public about the changes that are occurring. We will continue to do that, I think, regardless of what happens going forward. We see it as an important tool. We see it as a peer-reviewed way of getting the science and the communication of the science out there. So I don't foresee a change in our emphasis and our prioritization of the Arctic Report Card. I think it speaks for itself in its quality and its scientific integrity, and it's something we have every intention of continuing to do.
This is just a follow-up on what Marco was saying. I was curious to know how rapidly Greenland is losing ice right now, and whether the rate of ice loss is accelerating, and how much the ice loss we're seeing on Greenland is currently contributing to global sea level rise.
Well, the average, the Greenland is losing mass roughly about 230 gigatons a year, depending on how you see things. But that's a number roughly. And it's been accelerating until about 2012. There's been a slowdown in the acceleration since 2012, mostly because atmospheric conditions forcing melting have been still sustained, but there's been more snowfall over the east coast of Greenland, which is contributing, balancing some of the mass loss. Again, where mass is lost is extremely important, and this is something that we expect might be happening according to the models and the future projections. I think the contribution from Greenland to the sea level, I think the GRACE record is still, and the satellite data record that we use for the mass loss, so weight Greenland, is still too short, but best estimates are still the ones that we have from the IPCC published report. And we're updating those ones continuously, but I think those estimates are still valid. How reliable are those estimates? There are a lot of processes, the feedbacks in the Arctic and components, and how things are matching within each other is very important, and that's the best estimate we can provide.
We have some questions from the chat.
We have another one from Gareth. How do you respond, given this report card, to climate change deniers?
Guess that was me again.
I can add something about sea ice.
Sure. We don't write this report card for any specific audience. We write this report card, we put it through the peer-reviewed process so that it is beyond reproach. This is the best possible science that we can do and the best possible information that we can provide to the American people and to our leadership in the U.S. government around the world. So I don't think about messaging this report card to any one group of people regardless of their beliefs or their feelings. We provide the information and we allow people to make judgments based on the work of a fantastic group of scientists who put a lot of time and effort into the product.
In terms of the sea ice cover, I mean, we talk a lot about changing from 8 million square kilometers to 3 million square kilometers, and those are big numbers. But if you look at it, back in the 1980s, the September ice extent was around the size of the continental United States. If we look at this past year, 2016, it's as though part of the United States has melted. The entire United States east of the Mississippi, plus the states from Minnesota all the way down to Louisiana, plus all North Dakota. So the changes are significant. The changes are real. And we put these changes out there so people are aware of what's going on.
And also, of course, the Arctic Report Card is based on observations. It's evidence-based on the observations. The data is paid by the public, by the US public, through the federal government, and it's publicly available. So we are always open to, it's transparent, and I think it speaks for itself.
Another question?
Maura has a follow-up to her question about the impact on Arctic communities. She says, if there's time, are there also opportunities for Arctic communities, and what are they?
I think the answer to that question is yes. The opportunities for resource development, for tourism, for new shipping routes that may be opening in the Arctic, I think that the Arctic community as a whole, while they will face challenges over the next few years, will have the opportunity to take advantage of new commercial developments and new activities that take place in the Arctic. We just have to make sure that they're balanced accordingly and that no one gets left behind as the Arctic transitions.
We have one more question in the chat.
This one's from Matt Miller from KTOO in Juneau. He says, could someone explain the impact of less sea ice and more ocean warming into potential feedback? And what about impacts on the marine food web?
So if we lift this room and look from space at the Arctic sea ice cover, it's bright and it's white. It reflects most of the sunlight, reflects 80% of the sunlight incident on it. But when that melts away and you have an ocean, it goes from being a good reflector of sunlight to a really good absorber of sunlight. It absorbs over 90% of the sunlight, and that causes warming, which causes more melting, which causes more warming, and you get a feedback that's involved that way. And that's called the ice albedo feedback. But it's a way that you can take a small change and amplify it into a big change. In terms of the impact on marine ecosystems, there's a couple things going on that also, even before the ice melts away, it thins. In a simple sense, for phytoplankton, they need nutrients and they need light. And as the ice melts, they're getting more light, so you get these big blooms. And the question is the rest of the food web ready to interact with these blooms when and where they happen? And that's something that we just don't know at this time.
And Don, if I may add something also there, if you expose the ocean, you're changing completely also the way the surface interacts with the atmosphere. You change, the dense, the ice and the atmosphere are dense. You change the pace of the music. You change everything because exposing the ocean releases more moisture in the atmosphere, which in turn means energy and can be used for melting even more. We see these connections for Greenland, for example, between the sea ice disappearance and Greenland, and we see other connections about cloud formations and other things that might impact the atmosphere around the Arctic.
And I will add one thing. I can't sit up here and not say ocean acidification one time, for those of you who know me. So, the greening that's happening in the Arctic, this increase in primary productivity, is stimulating phytoplankton growth, which may have positive effects on the Arctic ecosystem. It may provide more food into the base of the food web. But at the same time, that primary productivity is the mechanism by which carbon dioxide is moved from the atmosphere into the ocean. And that's what ocean acidification is. It's the movement of carbon from the air into the water. So we already see a rapid progression of ocean acidification in the Arctic, And that seems to be accelerating as the ice melts back further and further and productivity increases. So on the one hand, we're going to be having more phytoplankton and providing more food into the food web, but on the other hand, it's going to be an exacerbation of the ocean acidification effect. So that's another process that we're going to have to pay very close attention to see what the balance is between ecosystem productivity and impacts associated with ocean acidification.
Are there any other questions from reporters in the room?
I understand that the Arctic and the Antarctic are very different environments, but I think sometimes it gets confusing as to why there's ice growth in Antarctica and then these annual report cards from the Arctic showing such dramatic change. So can you help put that into some kind of context and explain why looking at the Arctic is not just cherry picking a very dramatic region?
Well, I would say if it's raining in Italy, would you think that the same thing has to happen in the West Coast of the United States? I mean, they are completely different systems. It makes them, what joins them together is the fact that they are covered by ice. But the atmosphere, the ice, the size of the continent, the size of the ice, and how they react to the input from the atmospheric change in terms of system is completely different. So in this regard, I think Greenland, the Arctic, is an ocean surrounded by land. Antarctica is this piece of ice surrounded by ocean. The winds, somehow, circumpolar winds are protecting Antarctica somehow from spills of what mid-latitudes activities going on in terms of the atmosphere. Ozone hole, believe it or not, is responsible for some of the strengthening or weakening of these circumpolar winds. So it is a complicated system, and they are very two different systems. So I understand there might be some confusion, but this sounds to me like the postcard I saw once when somebody says, "Greetings from the Arctic," and it was a polar bear and a penguin. So it is confusing, but this confusion should not happen, I think.
Hi, Kit Stoltz, Santa Barbara Independent. From your remarks about the trends, it sounded like this fall in the Arctic might have been a little bit of a surprise. If so, can you talk about that, Mr. Perovich?
Yes, I mean, it was a record, and records are always, somewhat surprising. When I look at things, for me, the biggest surprise was in 2007. The Arctic sea ice summer extent reached an all-time record minimum by a record amount. And if you look at the time series of ice extent, it's never gone higher than it was in 2006. So it's as though we were in one state slowly declining, and then there was this sharp drop to a new normal that we've continued to bounce around. Some years are a little up. 2012 was another record minimum, but it's just there was this major change in 2007. And for me, that was a big surprise. I think it is interesting to see what's going to happen this year with the fact that fall freeze-up is so slow and the air temperatures are so warm. But it's still early in the year.
And for me, the surprise this year has been we've shifted a little bit. The stories have been about the summertime, summer minimums, summer temperature excursions, summer snow ice, summer snow cover. And now we're seeing the persistent warming carrying over into the winter months. So we don't know enough yet. We need a few more years to see if that trend continues or if it has been a one-off thing related to some larger global process. But if the persistent warming that we've seen this fall carries over for the next few years, then as Don just said, we may be at another step in a regime shift in the Arctic that will lead to a new era of change, even compared to what we're seeing now.
And as we pointed out also for Greenland, it's just not lasting longer. It's also starting earlier. We saw for the snow over the United States. So the melting season is also stretched, somehow getting longer, invading somehow spring and fall. And this is creating preconditioning before the current melt, but also is preconditioning potentially the next melting season. So there is really this stretch about the length of the melting season and the melt onset timing.
I think we have time for one last question.
My name is Mary Miller from the Exploratorium. You mentioned what stays in the Arctic, what happens in the Arctic doesn't stay there. Can you give us some examples of how, for instance, that extremely warm fall has potentially affected weather patterns, you know, in other parts of the world, maybe us down here?
Do you want to take that, Marco?
Well, I think there are people in the audience who can somehow link to this, and I'm asking them if they feel comfortable to speak, if they want to. But in the case of, for the atmospheric point of view and jet stream, and I'm just don't want to put Jennifer on the spot, but Jennifer Francis, she is here. But for Greenland, you know, in any case, where we talk about albedo, remember that also we're talking about large-scale phenomena. If the solar radiation is absorbed more by the ocean, there's less in the atmosphere. The gradient, the difference between the temperature at the pole and the mid-latitude is one of the drivers of climate on Earth, and that is changing, and that is impacting weather patterns and climate. But Jennifer is probably willing. I don't know if she's willing to say something, but I'll be more than happy to do so.
Sure. Oh, Jennifer Francis at Rutgers University. Thanks, Marco. So it's difficult to unravel how current or extreme weather that we've seen this fall, and there has been plenty of that, might have a role of the Arctic in it. I mean, that will be topics of research for sure. But that said, seeing an Arctic that's so much warmer than it should be all this fall by such huge margins, I can't imagine that there isn't going to be an impact on the weather that we've seen this fall. Over the last few years, we've noticed that when we have these big pulses of warmth in the Arctic, they are always associated with extreme weather events. And again, it's hard to make absolute definite connections between those two things, but we definitely see these causal relationships. And as Marco said, when the Arctic gets so warm and reduces this north to south temperature difference, we know that tends to have a slowing effect on the west to east winds of the jet stream. It tends to take these bigger north-south swings, and that all by itself is contributing to the warming of the Arctic. So it's helping to bring that warm air and moisture poleward, which is exacerbating the warming, which is maybe causing the jet stream to be even wavier. So we may be seeing this new feedback emerging between the warming Arctic and what's happening with the jet stream.
Thank you. We are out of time. That concludes our press conference. Thank you very much. And up next at 11:30, see you at 11:30 for new results from Gale Crater, recent findings from NASA's Curiosity Mars rover.